All right. So 6.2, number 31, here we go. Tangent, I've got a little tiny bug on my page. Anyway, so tangent theta minus cotangent theta. When you're trying to solve a trig equation, you have to try to rewrite everything in terms of one trig function, unless you can like factor. If you can factor the equation, then if you can factor the equation, then and each factor, factor in the product is just written in terms of one trig function, then that would also work. But in this case, I don't think there's really anything to factor. So I'm looking at this and I'm trying to think, how can I get this written in terms of one function? And there are multiple ways that you could go about doing that. Okay, but what springs to my mind immediately is that cotangent is just 1 over tangent, right? So immediately I can say tangent theta minus 1 over tangent theta equals 0. And now if I were thinking of this like if this were an algebraic function, like let's say this was x minus 1 over x equals 0, well then the next thing I would think to do would be to go ahead and clear that fraction by multiplying through by x. And so that's what I'm going to do here as well, only instead of x, I'm going to multiply through by tangent theta, right, to clear the fraction. Okay, when I distribute the tan theta, I get tangent squared theta minus 1 equals 0. And then I can solve from there, right? So you could either factor this as a difference of squares, right? Tan theta plus 1 times tan theta minus 1. Or you can just move the 1 over, square root both sides. Right? When you square root both sides on this step, you have to have a plus or minus sign over there. Right? But tangent theta is just plus or minus square root of 1, which is 1, right? Okay, so then from there you can think, well, so what are so let's split this into 2 equations and say, okay, so if I have tan theta equals 1 or tan theta equals -1, then what are the possible values of theta? Well, if tan theta equals 1, then one possible value of theta, and I think we're supposed to solve this in degrees. So we'll say one possible value of theta is 45 degrees. Okay, and then of course you're going to have a solution every, sorry, I was going to write 360, but actually every 180 degrees after that, you're going to have another solution. Okay, for tan theta equal to -1, what's one possible value? Well, if we're thinking about tangent inverse, then tangent inverse of -1 would be -45 degrees. And again, you're going to have a solution every 180 degrees after that. So those two solutions together describe all of the possible solutions to your original equation. Okay, in this particular exercise, we're only interested in the solutions that live between 0 and 360. So for the solutions that live between 0 and 360, we've got 45. That happens when I plug in 0 for n. When I plug in 1 for n, I get 225. Okay, that's also between 0 and 360, so I'm going to go ahead and put that in there. If I plug in 2 for n, then I'm at 360 plus 45, that's more than 360. Okay, so I've gone too far. This has gotten blurry all of a sudden, so let me try to fix that if I can. There we go. Hopefully that's a little better. Might help if I get other things out of the way. Okay. All right, so that takes care of the solutions that are generated by this rule. Now the solution is generated here. If I plug in 0 for n, I get -45, but that's not inside of the interval that I'm interested in. So I'm not going to use that solution. If I plug in 1 for n, I get -4 45 plus 180. In other words, 180 minus 45. So, oh, what's that? 135, right? So 135 is the solution. If I plug in 2 for n, then I'm going to have 360 minus 45, so that'll still be within the interval for sure. 360 minus 45, oh, what would that be? 315, right? So 315 is also in there, and then that's it, right? That does the trick. That's a very ugly curly brace, but you get the idea. So there's your solution set, right?